Problem 6-135. Add or subtract each expression below. Be sure to simplify. Starting out with letter A, we've got rational expressions that we're subtracting. So x squared over x minus 5 minus 25 over x minus 5. These ones already have the same denominator, so they have a common denominator. So we can take this and rewrite it as one fraction over the same denominator. So we're going to take away 25 from x squared. So we have x squared minus 25 over x minus 5. However, we're not finished. We need to look at our numerator and denominator, just like with any numerical fraction, to see if there is a factor that will simplify. So x squared minus 25 over x minus 5 is going to end up giving us, when we factor the top, it's a difference of squares, and we should be getting better at recognizing those. X plus 5 times the quantity of x minus 5. And that's over x minus 5. So because we have that now, we've got the same binomial in the numerator and the denominator, so this divided by itself is going to be 1. So in the end, we are left with just an x plus 5. Now, one way you can check that is choose a value for x, plug it in to this expression, and plug it into the original expressions, and it should give you the same value in the end. Let's look at b now. We have a squared over a plus 5 plus 10a plus 25, or that quantity over a plus 5. So a lot of times we look to factor first, but since I'm seeing that we have the same denominator, and this is going to make a trinomial if we combine it all together, what we're going to have here is a squared plus 10a plus 25 all over a plus 5. And you've seen enough trinomials now that you should be hopefully recognizing that this is a perfect square trinomial, which is going to factor into an a plus 5 times itself. You could say it's squared if you wanted to. But when we have a plus 5 times the quantity of a plus 5 over an a plus 5, we can now look to reduce. So this factor and this factor simplify to 1. So we have 1 times a plus 5 over 1. And that is simply going to be a plus 5. So very similar to the problem before, except there's not a difference of squares. It's a perfect square trinomial. Let's scoot on down here to letter C. X squared over x minus y minus the quantity of 2xy minus y squared over x minus y. And this is one of the ones where you have to be careful. You are subtracting all of this from x squared. So as we look to rewrite this as one fraction, I'm going to say x squared minus the entire numerator of our other fraction. And that is all over x minus y. So in order to simplify this, we're just going to distribute our negative through here, because we're going to take away a 2xy, and then we're going to take away a negative y squared. So x squared minus 2xy minus a negative y squared would be like saying plus y squared all over x minus y. Now this is going to actually end up factoring here, and you can factor it out using the box and diamond if you want to, or if you can figure it out without that, that's great too. We have x minus y times the quantity of x minus y. This is actually a perfect square trinomial. Now that we have that over an x minus y, again, we can look for common factors in the numerator and denominator, and we're left with x minus y. Last one, letter D. We have x over x plus 1 plus 1 over x minus 1. Now we finally have two fractions that do not have common denominators. So remember that we're going to have to multiply this denominator by the factor that it's missing, and the same thing on this side. So in order for us to have a common denominator, we're going to have, let me actually change color there. We're going to multiply by x minus 1 over x minus 1 on this side, which has a value of 1. And on the other side, we're going to multiply it by the missing factor that it has. So that would be an x plus 1 over an x plus 1. Now let's look and see what we have. We've got x times the quantity of x minus 1 all over x minus 1 times the quantity of x plus 1. We're adding to that 1 times the quantity of x plus 1, so really it's just x plus 1 up here over that same denominator. Let's now combine it into a single fraction. So I'm going to distribute this as I'm doing it. So x times x gives us x squared. X times negative 1 would be minus x plus an x plus 1 all over the quantities of x minus 1 times the quantity of x plus 1. Combine our like terms, and we get x squared plus 1 over x minus 1 times x plus 1. Now this is like the sum of two perfect squares, so it's different than the difference of squares. So this is actually as far as this is going to be able to go, because x squared plus 1 does not factor. So we get x squared plus 1 over the quantity of x minus 1 times x plus 1. You could also end up here, if you multiply this through, I should actually include that, you could end up with x squared plus 1 over, you multiply these, you should get x squared minus 1. Those are different binomials, so nothing will simplify. So either one of these would work. This is problem 6-135. Again, your simplified expressions, x plus 5, a plus 5, x minus y, and x squared plus 1 over the quantities of x minus 1 times x plus 1, or x squared plus 1 over x squared minus 1. If you have additional questions, make sure you ask your teacher. Otherwise, thanks for watching.